Good morning, all of you. My name is Shivansh, and my topic is random forest. So, before diving into random forest, let's talk about bagging. As random forest is a part of bagging, bagging stands for bootstrap aggregating. It is an ensemble learning technique. It takes a single unstable model like decision tree and make it highly accurate and robust by training multiple versions of it in parallel. It's like having same models, but each model taking different data. Okay, the most famous algorithm that use bagging is of course random forest. Okay, before diving into random forest, let's talk about what is bootstrap and what is aggregating. So bootstrap is a technique where we do sampling with replacement. Like we take a row out of a data set, then we take another row. Before taking another row, we put the first row we take back into the data set. Then we take another row. So we are doing sampling with this replacement. Yeah. Okay. And then aggregating. Aggregating is a voting. Voting. Uh, it can be hard voting, it can be soft voting. So here we do voting, like I have 100 models and 60 model predict 1 and 40 models predict 0. So here clearly winner is 1 because it has more votes. Okay, so this is bootstrapping and aggregating. So let's type into random forest. Random forest is not purely bagging, it is a specialized version of bagging. So, like we can say, all random forests are a form of bagging, but not all bagging is a random forest. Okay, it's not vice versa. So, let me tell you why it is not bagging purely. Okay, uh, here we inject two distinct type of randomness. Okay, first one is raw level randomness, which we talked earlier in bootstrapping. And another is column level randomness, which is feature sampling. Okay, let me tell you about more. uh, Here, if you can see here in this diagram, let's say I take a data set and I give this first tree my data set, then a second, then third. Okay, but if you please see clearly here, features, let's say I have 13 features, but tree 1 only giving we are giving root d features. Here d is total features, so we are root of 13 is like 4, so we are randomly taking 4 features only here. Then again in tree 2 we are taking randomly 4 features, so we are giving trees subset of features here. Okay, the bagging. When a standard bagging decision tree is looking for a best way to split a node, it look at every single features available in the dataset. It search all 100 features, find the absolute best split. Whereas in random forest, what we do when a random forest tree is looking to split a node, the algorithm artificially blinds it. It is only allowed to look at a random subset of features, usually root total features. So here this type of randomness we are doing at node level, and that one we are doing is at tree level. Okay. One question arises, why random forest is usually better. Okay, so imagine you have a data set has one insanely powerful dominant features. Okay, for example, in a medical data set, a patient heart is stopped. Okay, in standard bagging, because every tree see all features, every single tree will pick that exact same dominant features for its very first split at the top of the tree. Result, all 100 trees look almost identical. They are highly correlated. If they make a mistake, they all make the same mistake. But in random forest, because the trees are only allowed to look at a random subset of features at each step, many trees are forced to ignore the dominant feature. This forces the tree to learn from the weaker hidden patterns in the dataset, resulting the trees look completely different from one another, making the final ensemble much smarter and much more robust.